In this video, we'll address a question that I get asked all the time as a professor of psychology and statistics. In particular, it's this question here. Why study statistics in psychology in the first place? Why is this necessary? Now, I think that's a totally valid question, and it's one I'm going to get to at the end of this video. But before we get there, we're going to learn about a few sort of core statistical concepts that are going to be really important for us to understand moving forward. Now, let's start from the very beginning. What is statistics? I think when most people think about statistics, they envision something like this: an overly complex, really complicated field of mathematics that few people really understand. Now, I understand the sentiment there, but I do think it's a bit of a miscategorization and a misrepresentation of what statistics really is. Now, I'm going to give you a definition for us to sort of work with as we move forward through this series of videos. Here it is. Statistics is a set of tools and techniques that are used for describing, organizing, and interpreting information or data. These two words here just being interchangeable, information and data. Now, because statistics is just, a set of techniques that we can use to understand stuff about the world, understand information, I tend to think of statistics as more of a language than a math. And I think this is a bit controversial, but I think it's pretty true. Yes, numbers are involved in statistics, but in reality, statistics are all about learning about the world and, importantly, communicating what you learn to other people. If I were to tell you, for example, the average age of students in my class, I'm using statistics to communicate something to you, and that's what it's all about, just like a language. Now, I want to differentiate here between two different types of statistics. First, we have descriptive statistics, and this is where this series of videos will really start. Descriptive statistics are used to organize or describe, hence descriptive statistics, the characteristics of a data set. So you're not trying to generalize beyond your data set, you're just looking at the people you have in your study, for example. You're looking at your data set and you're just describing it. A great example of descriptive statistics, although there are many, are measures of central tendency, what we'll talk about in our next video. This is a fancy term here, but I'm sure you're well aware of what measures of central tendency actually are: means, medians, and modes. Now, these are simply ways to describe the center of your data set, so it's a descriptive statistic. Inferential statistics are used to make inferences about the data, that is, to generalize the data to maybe new groups of people. There are lots of these. Just as some examples that we'll talk about in future videos, we have t-tests and ANOVAs, which is just a shorthand for analyses of variances. Now, I want to really highlight this distinction here: samples versus populations, which connects back to what we just talked about on the previous slide. A sample is a subset of a population, and the population is what you really care about, whereas the sample is just a portion of that group. And let me say why this is really important through an example. So let's say you're a researcher and you want to know, this is your research question, this is what you want to figure out about the world. You want to know if male and female college students differ in how anxious they are. This is something that a social psychologist, for example, might really want to know. Now, I want you to quiz yourself here and think about what's the population, what's the group that you really care about. Well, hopefully you're thinking college students, right? That's what the research question's all about. We want to know if male and female college students differ in their anxiety. But this poses a problem. There are lots of colleges out there. This is just the top 1,400 colleges in the United States alone. And if you wanted to talk about all college students in the world, well, that group is going to be even bigger. It's simply not feasible for us to ask the, anxiety levels of every single college student at every single university and college that we're looking at here. We don't have the resources, and that's why we use samples. Instead of trying to ask everybody how anxious they are, we might pick, 2, 3, maybe 4 different colleges that we believe are representative of the rest, or perhaps we would randomly select 2, 3, or 4 colleges, and we would just ask some of the students how anxious they are. Now, we're working in that case with maybe, let's say 500 people instead of millions and millions. This is much more manageable, and using inferential statistics, which we'll learn about later, we can take that 500 and use the information they provide to sort of make generalizations, inferences, and conclusions about the millions. And this is really the power of statistics, the ability to make those conclusions. But I want to get back to this question here. Why am I studying statistics if I want to be, for example, a psychologist? Now, the answer is pretty simple. Psychology is a science. A lot of people don't realize this because in pop culture, we think of psychology as sort of, therapy. And while therapy is certainly a big, important part of psychology, there's science behind it, right? We need to know, for example, what sorts of therapies are effective. We have cognitive behavioral therapy, we have psychodynamic approaches. There's all these sorts of things that are evidence-based. That evidence is science, right? And in order to do science, in order to make scientific conclusions that we're confident in, we need statistics. And that's really the backbone of why we're doing this. Let's take an example. Let's go back to that example of the researcher who wants to know if male versus female college students differ in how anxious they are. Now, I'm going to just write here. Let's say that we actually did this study. Let's say we got 250 men, and let's say we got 250 women, all in college. And we asked everybody, how anxious are you? On a scale of, let's say, 1 to 10, 10 being extremely anxious, 1 being not anxious at all. Now, let's say we found the average levels of anxiety of the men and the women. Let's say the men scored, like 6.3 out of 10. So slightly above average, right? They're in college. There's a lot to think about. And then the women scored 6.7. How about that? Now, in this case, we have to ask ourselves an important question. Do we think that women are more anxious than men in college? Now, we're certainly seeing a difference of 0.4, it looks like here, right? 0.3 versus 0.7, with the women being more anxious. But the question is that something that's specific to this particular group of people? Or can we generalize that to all men and women in college? And that's an important question. That's the one we really want to answer. You can think about possible alternatives. For example, maybe we just happened to get some women in the study who were particularly anxious, a little more anxious than you would typically find in college. Or on the other side of things, maybe you happen to just find a group of men who were more relaxed than usual, or there were some outliers, for example. Now, these are things that would skew our conclusions without inferential statistics. It's perfectly possible that if we did this study again a second time, maybe the men would be more like 6.8 and the women would be slightly less anxious, and your conclusions would flip. This is why inferential statistics and statistics more broadly is so important. We can make with confidence these sorts of conclusions to say that this difference of 0.4 is big enough for us to be convinced that women are more anxious than men in college. Just looking at the raw numbers alone, we can't make that conclusion. So just as a kind of final note or two, I want to say that statistics is important for both producing science, what we just saw here, but also, as I'll mention in a second, consuming science, learning and understanding all about science. Now, I've already shown that without statistics, you wouldn't be able to evaluate your hypotheses about the world. You wouldn't be able to make any conclusions. And just, kind of connecting things practically, if you're interested in pursuing a PhD, even a clinical PhD, a lot of people don't understand that, you'll be doing lots of research, and research is science, and science requires statistics, so you'll be using statistics quite often. But again, even if you're not interested in pursuing a PhD, statistics is important for consuming science. You can think about everyday life, watching the news, going on social media, stock market stuff, and a million other examples. There's all sorts of situations in which understanding statistics gives you the ability to really excel, to evaluate claims that are presented to you in an educated way, maybe to make money on the stock market, all sorts of applications. And again, just kind of connecting to the sort of applicable side of things here even more, let's say you do want to go on to grad school but not get a PhD, you want to get a master's degree, consuming science is going to be critical. You may not be producing it, you might not be doing research, but you're going to need to read articles to understand the science behind what you're learning. And so I encourage you as we move forward through these videos to really think, about why this matters, why we're doing the things that we're doing. Don't get lost in the nitty-gritty. Continue to kind of contextualize why this all matters, because it really does matter.